Have you ever stopped to think about what makes everything happen? What is the driving force behind every action, every movement, and every change we see around us? From the smallest atom to the largest galaxy, it all comes down to one amazing thing: energy. It's the fundamental building block of the universe. Energy is the invisible force that powers our world. It's harnessed in countless ways, from the wind turning turbines to the sun shining on solar panels. It's what makes cars go, phones light up, and plants grow. Every gadget you use, every vehicle you ride, and every plant you see thriving owes its existence to energy. Without energy, everything would come to a standstill. Imagine a world where nothing moves, nothing grows, and nothing functions. Pretty wild, right? Think about it. You couldn't throw a ball without energy. Every sport, every game, and every playful activity relies on it. Your dog couldn't chase a squirrel. Every leap, every bound, and every playful chase is powered by energy. Even reading this essay requires energy. Your brain needs it to process information, and your eyes need it to see. It's everywhere and in everything. From the bustling city streets to the serene natural landscapes, energy is the heartbeat of our world. In this wild ride of an essay, we're going to explore the awesome world of energy. We'll uncover its secrets and marvel at its wonders. We'll learn what it is, the different forms it takes, and how it shapes our lives. From kinetic to potential, thermal to electrical, energy is a versatile force. Buckle up, it's going to be an energetic journey. Get ready to be amazed by the power that makes our world go round. So, what exactly energy, you ask? In the world of physics, energy is the ability to do work. Work in this context doesn't just mean your homework or a job. It means anything that involves a force causing movement or change. For example, when you lift a heavy box, you're doing work. You're using energy to overcome the force of gravity. When a car accelerates, it's doing work. It's using energy to increase its speed. Energy is measured in units called joules, or J. 1 joule is the amount of energy needed to apply a force of 1 Newton over a distance of 1 meter. But don't worry too much about the numbers. The important thing is to understand that energy is what makes things happen. Energy is all around us, in many forms. The sun provides solar energy, which plants use to grow. Wind and water can be harnessed to generate electricity, another form of energy. Even the battery in your phone stores chemical energy, which powers your device. The food we eat provides us with energy to move, think, and live. Fire releases thermal energy, which we use for cooking and warmth. Electrical energy lights up our homes and cities. So, next time you see something moving or changing, remember it's energy at work. Energy is the invisible force that powers our world, making life vibrant and dynamic. Let's start with kinetic energy, the energy of motion. Anything that's moving possesses kinetic energy. The faster it moves, the more kinetic energy it has. Imagine a speeding bullet train. That's a lot of kinetic energy. Or think about a baseball flying through the air after a powerful swing. Kinetic energy in action. The amount of kinetic energy an object has depends on its mass and its velocity, or speed. A heavier object moving at the same speed as a lighter object will have more kinetic energy. And of course, the faster an object moves, the higher its kinetic energy. Now, imagine that same baseball held high in the air just before it's thrown. It's not moving, but it has the to move. That's potential energy, stored energy that's ready to be unleashed. Think of a stretched rubber band or a roller coaster poised at the top of a hill. They're not moving yet, but they have the potential to unleash some serious energy. Potential energy is all about position and the forces at play. The higher an object is above the ground, the more gravitational potential energy it has. The more tightly a spring is compressed, the more elastic potential energy it has. Ever wonder what makes things hot or cold? That's thermal energy. Thermal energy is the internal energy of a substance due to the movement of its atoms and molecules. The hotter something is, the faster its particles are moving, and the more thermal energy it has. Think about a steaming cup of hot cocoa on a chilly day. The cocoa has more thermal energy than the cold air around it. Or picture a sizzling frying pan, lots of thermal energy there. Thermal energy is always on the move, flowing from hotter objects to cooler ones. That's why your cocoa cools down over time. It's transferring its thermal energy to the surrounding air. Chemical energy is stored in the bonds that hold atoms and molecules together. When these bonds are broken or formed during chemical reactions, energy is either released or absorbed. Think about the food we eat. It contains chemical energy stored in the bonds of its molecules. When we digest food, those bonds are broken, releasing energy our bodies can use. Batteries are another great example of chemical energy. Inside a battery, chemical reactions take place that release stored chemical energy as electrical energy. Electrical energy is the energy associated with the flow of electric charges, those tiny particles called electrons. It's what powers our homes, charges our devices, and makes lightning flash across the sky. Electrical energy is all around us. It flows through wires, powers our appliances, and even exists in our bodies as nerve impulses. Think about turning on a lamp. When you flip the switch, you're completing a circuit that allows electrical energy to flow, causing the bulb to light up. Section 8. Energy transformations, from one form to another. Now, the really cool thing about energy is that it can change forms. This constant transformation of energy is happening all around us. Let's look at a simple example, a bouncing ball. When you hold it in the air, it has potential energy. As it falls, that potential energy is converted into kinetic energy. When it hits the ground, some of that kinetic energy is transformed into sound energy and thermal energy. Or consider a car engine. It converts chemical energy stored in fuel into thermal energy through combustion. This thermal energy is then transformed into mechanical energy that turns the wheels, making the car move. Energy transformations are the backbone of our modern world. Section 9. The law of conservation of energy. Energy can't hide. Here's a fundamental law of physics. Energy cannot be created or destroyed, only transformed from one form to another. This is the law of conservation of energy, and it's a big deal. This law tells us that the total amount of energy in the universe is constant. It might change forms, but it never disappears. When you burn wood in a fireplace, the chemical energy stored in the wood isn't gone. It's transformed into heat and light. The law of conservation of energy helps us understand how energy flows in the universe and is essential for designing efficient energy technologies. Section 10. Energy in our lives powering our world. It's impossible to overstate the importance of energy in our lives. We rely on it for everything. Think about transportation. Cars, buses, trains, and airplanes all need energy to run. Most of this energy comes from fossil fuels like oil and gas. Our homes and businesses need energy for heating, cooling, lighting, and powering our appliances. This energy typically comes from power plants that burn fossil fuels or use other energy sources like nuclear or hydroelectric power. Energy is also essential for communication. Our phones, computers, and the internet all require a tremendous amount of energy to operate. Section 11. Energy for the future. The importance of sustainability. As we've seen, energy is the lifeblood of our modern world. It powers our homes, fuels our transportation, and drives our industries. Without it, our daily lives would come to a standstill, but our reliance on fossil fuels has consequences. The burning of coal, oil, and natural gas releases harmful pollutants into the air. Burning fossil fuels releases greenhouse gases into the atmosphere, contributing to climate change. This leads to rising global temperatures, melting ice caps, and more extreme weather events. That's why it's so important to find cleaner, more sustainable ways to power our planet. Renewable energy sources offer a promising solution. We need to transition to renewable energy sources like solar, wind, hydro, and geothermal power. These sources harness the natural processes of the earth to generate electricity. Renewable energy sources are constantly replenished by nature, so they offer a cleaner and more sustainable alternative to fossil fuels. Unlike fossil fuels, they don't deplete over time. Investing in renewable energy technologies is not just about protecting our environment, it's about securing a brighter future for generations to come. By supporting these technologies, we can reduce our carbon footprint and create a more resilient energy system. So there you have it, a whirlwind tour of the amazing world of energy. From the power that lights up our cities to the fuel that drives our cars, energy is an integral part of our lives. Remember, it's the invisible force that makes everything go, and understanding its different forms and transformations is key to appreciating the world around us and building a more sustainable future. By learning about energy, we can make informed choices that benefit both our planet and our communities. Keep those questions bubbling and that curiosity burning bright. The journey to a sustainable future starts with each one of us, and together, we can make a difference.